Hello, today we're going to be going over relative max. So, what I like to do, the thing about relative max is you're looking at a, say that you have f of x and you have negative, or just 1 over x. Um, it's going to be something like that. I'm really bad at drawing graphs. So, you're going to be wanting to know, like, what the, say that on this I would give you an interval. It'd be like 1, 2, or something like some stupid thing like that. This is a pretty bad interval. Say this is like 1, this is like 2. I want to find what the lowest point on here is. Um, so I would take the derivative. I would set it equal to 0. So let's mark this down. Take the derivative of a function. Whenever you, pretty much when you're on the integral or when you're on the derivative part of any calculus exam, um, since most are like structured like limits, derivatives, integrals, you're gonna want to you're just gonna want to, if you see an f of x equals and then any function, just instantly take the derivative. Um, and then start reading the question as you're taking it. You know, unless it's a derivative that proves to be really difficult or just like really time consuming, like a whole bunch of like a product rule, a chain rule, and quotient rule together. Just like some really time consuming something. Um, just like just take the derivative first. Generally, on every single AP exam that I've ever seen, most derivative functions are going to be pretty obvious, or most functions are going to be pretty obvious whether or not you even can take a derivative with calculus AB. Um, so yeah, just take derivative. Then you're gonna want it to then you're gonna want to set it equal to 0. Setting it equal to 0 essentially serves as like, look at like any graph. Like say that we have like a parabola like this. Um, you know, the thing about, surely you know at this point about what a derivative actually is. Um, there are plenty of resources. I'm sure your teachers have told you what it is. So one thing about derivatives is that they equal 0 when they're changing sign. When the f of x is changing sign to be positive to negative or negative to positive, they always equal 0. They have to. Um, because you can't. It's mean. It's one. It's like kind of like mean value theorem. Like you can't get from like 1 to 2 if you're linear and continuous without going past 1.5 or 1.1 or basically an infinite amount of numbers in between the two. But 0 has to be one of those numbers. So going from positive to negative, you have to, or negative to positive, you have to equal 0 at some point. And the x values that it does actually that make the equation of the derivative equal 0 are called critical numbers. Um, so say that like this parabola, for some reason, this point up here where it equaled 0, where the derivative equals 0, was x equals 2. Um, derivative is equal to like x minus 2 or some crazy thing like that. You set it equal to 0, x equals 2. This is your critical number. The point at which the point for your x value at which the derivative equals 0 is your critical value. No ifs and or buts. There is some weird stuff where like if it's on the edge of your interval, does it count? If it makes your function um like one over x is 0, a can 0 be a critical number? You know, AP, like any standardized test, will really never ask you that sort of question because it varies from calculus book to calculus book, and you know, it's just a bad question to sort of ask a student who, may have not studied um, calculus extensively or been told of even the existence of that sort of weird conjecture. Um, so you find your critical values, you test them. So with testing, what I like to do is use a number line Now, stuff like AP will not accept a number line as reasoning. You cannot write you if you get one of these problems on an FRQ. It would just be like one part of it, like ABCD. You cannot take this, find the you cannot do all this, and then for testing just put this, and then for reasoning just say my number line said it. Um, it'll always give you the right answer, and it is one of the easy it is for me the easiest way of testing it outside of having like a graph. Um, and just graphing it. But it is the easiest way to do by hand by far. And yeah, that's how I like to do it. So essentially, say that like 2 is your thing up here. You want to and you want to know if it's a relative max. You want to take 2, plug it in the middle, and find values on either side of it. So with a max, you know up here this derivative is going to be positive because slope is positive. So this side has to be positive. It must be. For this to be a max, this has to be positive. So let's say I take 1 and 3. Um, you want to pick numbers that are within, 2 to 5 of your actual thing, depending on your interval and depending on the type of graph. Trig is a little bit weirder because with trig, you're using like pi and radians and stuff. So your radians are going to be weird, and oftentimes your interval will not be just unbounded. It's not, well, it won't ever be that because they oscillate. Like cosine and sine will oscillate. So looking at this, looking at this graph, I can tell you with absolute certainty that 1 and 3, 1's positive, 3 is negative. Absolute certainty. So this checks out. This is a max for this function. So yeah. And then 5, on AP, you just do whatever. You literally just do whatever. The rest of the question asks you. It may ask you to, um, like plug. I don't. I mean, it may ask you to plug back into and find the y coordinate. I've seen that before. Like, what is the relative max, and you have to plug in and find what your f of x portion of it is. Um, so at that point, you would literally just take x equals 2, plug 2 in for x. It wouldn't work on this instance because 0, but or it may if 0 is, but you would just plug in this. Say that this is like 2. It's like find the absolute max, or find the relative max, not absolute. Find the relative max for this function. You would just type in, or you would just write. You could either write 2 equals x, or you could write 2 equals f of x. Both are technically correct. It would depend highly upon how the question is written, and I highly doubt that AP would ask you. I think AP would accept either because they both say the same thing. So just do whatever the question asks. Okay, so knowing what you know about that, let's find the derivative of, or let's do that for this. So f of x, yikes, f of x equals x minus 2 times x minus 3 squared. So first thing I do is I take the derivative. I see its product rule, and I see its power rule as well. So I do x minus 2 times, just get that product rule out of or get the power rule out of the way, so if I made a mistake, I can just instantly fix it. 2 times x minus 3 to the first. I think we got it, guys. I think we got it. Or chain rule as well. I mean, chain rule, power rule, same thing. Because power of an equation sort of is technically chain rule, but it functions the same as power rule when the inside is just an x or something, and the derivative is equal to 1 or 0. Obviously here you would take the derivative, but it's just 1 of the inside, so then it doesn't really matter. Same thing here. The derivative of x minus 2 is literally just 1, so x minus 3 squared. This is your derivative, so you want to set this equal to 0. So x minus 2 times 2x minus 6 plus x minus 3 squared equals 0. Now, for a while, I think I sat here and tried to find values or ways to solve this problem just from this point. It's possible, and I'm sure you could do it if you had enough time. But in a timed exam, that's really not the way you want to approach this sort of problem, especially when you're in this sort of, I could easily do this in my head, and this is just distribution. So, 2x squared minus 6x minus 4x plus 12. There, that's that part done. Then plus this, x squared minus 6x plus 9. There, still equal to 0. Now, at this point, you could just once again do the same thing up here where you could like look and try and find values that fit this and make this true. If you were going to do that at any point, this was probably going to be your best bet. So at this point, if you decide to go this route, you're really just going to be foiling it out and trying to get it in a different form. Minus 16x, because this becomes negative 10x plus negative 6x. And then 12 and 9 is 21, I mean. So there, that equals 0. Now, the way that normally how I would solve this is, hey, look, we combined these two things up here, did all this work, and now we're left with this basically like low tier polynomial. And or quadratic or whatever the hell it's called. In a lot of instances you could literally just factor, say that we didn't have a 3 here and that this wasn't a 21 and this was like some like nice number that actually was cool about being in this whole problem. You could just find like, hey, like x minus 3 times x plus 9 or some dumb shit like that if it worked. That doesn't happen in this problem. So what I just did is I was just like fuck it, and I'm just gonna plug it into a graph and see if I can rule out any of these things. So that's basically what I did. I just plugged it into a GeoGebra graph. If on the exam you'll have a TI-84 or whatever the hell your school uses as TI-83, and yeah, that's just how I solved it. I think that's the easiest way. Especially since up here they didn't even give you like 1, 2, 3. They gave you fractions that I'm pretty sure no one knows. I mean, I know 2.5, but like 7 over 3. Like, obviously I know that's 2 and 1/3, but like, ew. I'm not about to do. I'm not about to plug 7 and 1/3 into this problem. So I just made a graphing calculator, or I just used a graphing calculator. And as you can see, it's a parabola, obviously, because it's x squared. So it's going to have 2 x intercepts, but none of them are negative. None of them are negative. So I just went ahead and just plugged straight. I just completely removed these 3 options. Now I'm down to just these 2. Looking back at it, you could just instantly go ahead and say you would need to scroll in, and on your TI-84 or I have a TI-84, so I know a little bit more about how that works. I'm pretty sure it works on the same way with the TI-83. If you go to table and like press plus, at 0, at x equals 0, and you put in like 7 and a third in this case, it'll instantly put you to 7 and a third x, 7 divided by 3x for your x value, and you can just see what the y value is. That's honestly like such a useful tip. It's like not even funny. So I know that 5 divided by 2 is 2.5. That's pretty basic. So obviously 3, positive 3 is one of them, but 2.5 is not one of them. It looks like looking through here, just zooming in because I can tell that this is just 2.33. It even looks like it's closer to 2.34. I think it's because I don't actually know why that it does. Because 2.33 would not round to 2.34, it would round to 2.32. So I would think that'd be somewhat closer to here. But anyways, so yeah, that's kind of how I ended up eliminating, you know, these or this one, and I got this as my answer. Um, Another, if you wanted to be sure, what you could do, you plug 7 and a third in. Um, Yikes. Plug 7 and a third in for x. You will get it equals 0. I would bet money that you would. Um, and then you can make an, if you want to verify that even further, because you just have all the time in the world on this AP exam, um, or whatever you're taking, GRE. Uh, so you would just plug in 7 and a third. You would do the number line analysis that I was talking about earlier. Just by the nature of this problem, it wasn't necessary. But had this not been so weird and not been so XD, like screw you 21, that and screw you 3, because I hate freaking this shit. I would have just done number line analysis. I would have found my two critical numbers and then done number line analysis. So I know 7 and a third is 2.1 third. So I'll just do 2 here and I'll just do 3 here because it's on either side. It's really close. So it should give me a very accurate estimation. Since it has to be relative max for it to be that, the left side has to be positive, the right side has to be negative. So this is going to be positive, this is going to be negative. Um, just looking at 12 minus 32 plus 21, that's positive. 12 plus 21 is going to be, it's close to 0 on the positives, but it's still on the positive side. Negative, so 3, 927 minus, what is that, 54? Minus 54 plus 21, that's obviously negative. So here, that's negative. So this all checks out. So 7 and a third is definitely your answer. Uh, Thanks for watching, boys.